Here are the answers to the quiz on Experience 3 in this Unit 2 on the periodic table. So the first question asks us about the radius of chlorine versus fluorine. And we can see from the picture that chlorine has a larger radius, and we want to know the reason why. So which of the following statements best explains this observation? If I look at the periodic table, fluorine and chlorine are in the same group, going up and down. Like for example, here is fluorine, number 9, and then chlorine. Below it is number 17. The reason why the radius is bigger is because of the energy levels. There are electrons distributed amongst 3 energy levels in chlorine, but only 2 energy levels in fluorine. The biggest factor that affects radius when the atoms are in a group going up and down is the distance between the nucleus and the outer electrons. And each time you go down the group, you're putting electrons in a higher energy level. So they're farther from the nucleus, bigger electron cloud. Now, some of the other choices are not wrong statements. They're not false statements. Chlorine has nearly twice as many electrons as fluorine. Yep, it does. Chlorine has nearly twice as many protons as fluorine. Yes, it does. Fluorine atoms have 9 protons and 9 electrons, and chlorine atoms have 17 protons and 17 electrons. And yes, the mass of chlorine is about twice the mass of fluorine. And fluorine's mass is about 19, and chlorine is about 35. So they're not wrong statements, but they don't explain why the radius is bigger. Yes, there are more electrons, and it's the electron cloud that makes up most of the radius of the space in an atom, but it's really the fact that they're distributed amongst more energy levels, not just that there are more, because there are times when you might have atoms that have more electrons, but they're not in higher energy levels, and then they're not significantly changing the radius. So again, be careful with the last 3 statements here. They're not wrong, but they don't accurately explain the observation. So now when you get this on a summative, it just wouldn't be multiple choice, and you would explain why. Energy levels going down a group. That's what affects the properties going down a group. More energy levels, electrons farther from the nucleus. Now going across is another story. Going across from element 11, which would be sodium, to number 17, chlorine. This is sodium. This is chlorine. Now we're going across the periodic table. Sodium way over here is number 11. And then all the way across to the P block, I'd hit chlorine number 17. Okay, so this is a different situation. Now we're going across. And yes, we're adding electrons, but we're adding the electrons to the same energy level. We're just filling the 3rd energy level. So it increases as electrons are added to the energy levels or higher energy levels. No, electrons are added, but not to higher energy levels. It remains constant because the electrons are all added to the 3rd energy level. Well, part of that is right. The electrons are all being added to the 3rd energy level, but not only are you adding electrons, but you're also adding protons. And so yes, the 4th statement is true. The atomic number increases, but it's not necessarily the nucleus that's making or having any effect on the radius. The nucleus is like a marble in the middle of a giant NFL stadium. And so, yeah, maybe my nucleus is a little bit bigger, but what's the deal? I mean, if you have a bigger marble in the middle of Lambeau Field, that really doesn't have a proportional effect on the size of the atom. It's that the nuclear charge is greater, and that increases the attraction. So sodium has 11 protons and 11 electrons. Chlorine has 17 protons and 17 electrons. And the key is that all of these electrons are just filling the third energy level. So yes, we're adding electrons, but they're all going in the third energy level. So on average, they're about the same distance from the nucleus, until you factor in the fact that more protons will create a stronger magnet on the inside of that atom. So when we say greater nuclear charge, we mean more positive nucleus. Because there's more protons in the nucleus is more positive, and it has a stronger attraction for that third energy level. So all of those electrons in the third energy level will just be more attracted to the nucleus, and that will make the atom smaller. Awesome. Here's a graph of radius and atomic number. There's a couple different ways you could have answered this question, and it's just asking which letter would represent sodium. One of the easiest ways is just to count the dots, right? And sodium is element number 11. So you could just count to the 11th dot, and it should be element C, that's sodium. But now what is kind of interesting is that if you mark in a couple of the elements from that first group, element number 1 or the first dot would be hydrogen. Element 3, the third dot is lithium. Then we've got sodium, and we'd have potassium, which would be the 19th dot. But this graph kind of shows the trend in radius. That if I look at a group going down from hydrogen to about potassium, the radius should increase. If I look at a group going across, the radius decreases. So for example, if I take lithium, and that's element number 3, and then 4, 5, 6, 7, 8, 9, 10. So like this dot here would be neon. Going across, the radius decreases because of the stronger attraction between the nucleus and the electron cloud. But going across the radius, or I should say going down a group, the radius increases because of the higher energy levels. So it's all kind of summarized on this graph. Pretty cute, huh? Here is a graph of ionization energy versus atomic number. Which of the statements below is true regarding the trend in ionization energy between lithium and neon? And so I can look at the graph, that I don't have to memorize these trends. Don't feel like you have to memorize the trends. Like, okay, if I go down a group, it does this. If I go across a group, it does that. They're telling me the trend. I just have to look at the graph. So if I look at lithium to neon, I see that ionization energy in general increases. Now I just have to be able to explain the why. And that's what you're going to do on the summative, right? So on the summative, it's going to be really similar. It's going to be a lot about the why. It's telling me the trend. Okay, so we just said that as you go across, the attraction increases. Well, ionization energy is the energy required to remove an electron. Well, if I'm talking about a stronger attractive force between the nucleus and the electrons in neon, then it should take more energy to remove an electron. It's due to that greater attraction between the nucleus and the electron cloud. And that attraction is greater basically because of the nucleus having more protons and the electrons all being about the same initial distance. They're all in the same outermost energy level. More energy is released. Well, right there, these first two are wrong. Ionization energy is energy that I have to add. I have to add energy to remove an electron that's attracted to the nucleus. They're magnets. They're attracted to each other. The third choice, more energy is required to remove an electron due to electrons being distributed amongst more energy levels. Nope, they are not. They're all being distributed amongst the same energy level. So from lithium to neon, we're just filling the second energy level. Here's a good question. Don't get so bogged down by the numbers or these units. We just want to think about the trends in radius and ionization energy going across. And so I looked at my periodic table to find potassium and calcium. They're right next to each other going across the period. Okay, so they give me a measurement for the radius of calcium in units of picometers, teeny tiny fractions of a meter. And they give me a measurement of ionization energy in units of kilojoules. So that's just a common unit of energy. I just want to think about the trends between calcium and potassium. So going across, calcium has an extra proton and an extra electron. So even though they're still filling the fourth energy level, because of that extra proton and an electron, the attraction in calcium should be stronger, right? So in calcium, in general, there should be a stronger attraction. There's an extra proton and an extra electron. Okay, so a stronger attraction, which then means that potassium would have a slightly weaker attraction. Weaker attraction between the nucleus and the electrons. Well, if the attraction is weaker, that should make the atom a little bit bigger. So I'm looking for a radius that measures a little bit greater than 194. So yeah, like that 242 seems reasonable. And then ionization energy. Okay, so if it's a weaker attraction in potassium, then it should take a little bit less energy to remove an electron from potassium. So I'm looking for something a little bit lower than the 590. Yeah, like 419. So again, it's not that the numbers are that important or that the units are that important. It's the trend. Is the radius larger or smaller? Is the ionization energy larger or smaller? And it all goes back to the degree of attraction between the nucleus and the electron cloud. I mean, I feel like when you take this summative, that's going to be like your answer for every question, right? I have to think about the attraction. Is it a strong attraction or a weak attraction between the nucleus and the electron cloud? And I love question 6. There were 2 bottles in the lab and the labels fell off. We knew that one was magnesium and one was calcium. Your lab partner says it's possible to determine which label should go on which bottle by observing the reactions between a small amount of each metal in the separate beakers containing different quantities of water, or I should say equal quantities, different beakers. Okay, so if I know anything about these trends, and I look at magnesium versus calcium on the periodic table, they're in a group going up and down. So calcium should have a larger radius. It's got electrons distributed amongst more energy levels. A larger radius would mean that it should be easier to lose valence electrons, because then they're not as close to the nucleus, and so they're not as strongly attracted to the nucleus. That attraction is weaker. Okay, so larger radius would mean it's easier to remove the outer electrons. If it's a weaker attraction because the electrons are farther from the nucleus, there should be lower ionization energy. It takes less energy to remove the electrons, and that makes it more reactive. And particles are really reactive if it's either easier to remove electrons or easy to gain electrons. Whatever it takes to get that full outer shell. That's the point of a chemical reaction, is we're changing the structure of the atom to fill the outer shell. And so if it's really easy to either lose electrons or if it's really easy to gain electrons, those are going to be some of my most reactive elements. Oh, I love this one. And we're almost to the end. Number 7. I love this question too. Would these properties be associated with a strong or a weak attraction between the nucleus and the electron cloud? And so I think if there's a small radius, then that means that the electrons are pretty close to the nucleus, so there should be a strong attraction. Low ionization energy would mean that it does not take much energy to remove the electrons, so the attraction is weak. High electron affinity energy means that I lose a lot of energy when I gain electrons. If you think about the word affinity, if you have affinity for something, it means you like something, you want something. Like I have an affinity for dark chocolate. I love it, I want it, I need it. Just a little bit, every single day. Well, electron affinity is atoms that really want electrons. They really want to gain electrons. And when they do so to fill their outer energy level, they release a lot of energy. And so high electron affinity would mean a strong attraction within the atom, and then even a strong attraction for maybe neighboring electrons. I really want to gain electrons. High reactivity would mean a weak attraction between the nucleus and the electron cloud. So these would be particles like at the bottom of your periodic table that have electrons really far away from the nucleus. And that weak attraction makes them highly reactive. And then finally on this one, number 8, ionization energy is energy that you have to absorb to remove an electron. Because again, the electrons are attracted to the nucleus. So if you're going to split them apart, you have to add energy. But electron affinity is energy released when we gain electrons. So they're kind of opposites. When I gain electrons to fill the outer shell, I make that atom more stable, and then energy is released. And here's the end of her. Here's the last two. So number 9, which of the following elements will have the highest electron affinity energy, which means they're like most likely to gain electrons. They really want to gain electrons and then lose energy. Of all elements with electrons distributed amongst 3 energy levels. Ah, that's tricky. So 3 energy levels would mean I'm really only looking at the 3rd row or the 3rd period going across. So my answer is going to be like sodium, magnesium, aluminum through chlorine and argon. That's what electrons distributed amongst 3 energy levels means. That we're going across the 3rd period or the 3rd row. So of the elements from, sodium all the way across to argon, which element is most likely to gain electrons? It should be chlorine. And you could think of it from a couple different standpoints. I mean, number 1, chlorine does have 7 valence electrons. 5 electrons in the 3p orbital. And so all I have to do is gain 1 more. If I gain 1 more electron, boom, stable, full orbitals. That's pretty easy to do. And so it's likely that that will occur. The other way you could look at it is that of all the elements going across the 3rd period, besides argon, and it's not on the list here, chlorine should have the greatest nuclear charge. It's got the most protons. So it's going to have like the strongest magnet in the core of the atom. So it should be the most strongly attracted to electrons within its own energy levels, and then maybe even an electron from a neighboring atom. Somehow I want to gain an electron. Awesome. And now it's not on the list. Argon is not on the list. But we should make note too that even though technically argon would have an extra proton and a stronger nuclear charge, argon is a noble gas, and it already has its outer energy level full with 8 valence electrons. It would end 3p6 for a total of 8 valence if you add in the 3s too. And so if argon is already full, it doesn't need to gain electrons. And so it would really never talk about electron affinity energy in reference to a noble gas. They don't have any business gaining electrons. And then at the end, number 10, check all that apply. Which of the following are true in regards to the calcium atom versus the calcium ion? Okay, so atoms versus ions. The ion is charged. We've either gained or lost electrons to fill the outer energy level. And so I just kind of sketched out the electron configuration for calcium to kind of see what that outer energy level looks like. And so my highest energy level is the 4th. So I'm going to have 2 valence electrons. All the rest of these guys are my core electrons. They're all full in their orbitals. But here's my valence electrons. I've got 2 of them. Okay, so 2 valence electrons, but I'd really like 8. So my choice is to either lose those 2 or try to find 6 more. Whatever deals with the least amount of electrons is probably what's most likely to occur. So in this case, let's just lose 2, right? If we just lose these 2, now my outermost energy level would become the 3rd. That would be my new valence shell. And my 3rd energy level would be filled with 8. All the orbitals are full. Okay, so the calcium atom would have the 20 protons and 20 electrons. It's neutral. But I'm going to lose 2 electrons when I form the ion. I am not changing the protons. We're not going to touch the nucleus when we make an ion. But we are going to lose 2 electrons. So the first choice is not right. And maybe when some people see that the second choice is correct, that yes, the charge is +2, but it's not +2 because you've got 2 extra protons. Element 22 is titanium. And we're not going to change the identity of the atom. The charge is +2 because it's a balance between the protons and electrons. If I lost 2 electrons, but I didn't change the number of protons, that means I'm going to be left with 2 extra positive protons. So yes, my charge is +2, but it's not because I gained 2 protons. Now the calcium ion will have a higher ionization energy than the calcium atom. Yes. And so I think about it this way, that I've got 20 kids and I'm taking them on a field trip. I got 20 kids and I got 20 teachers. Cool. So it's like 1 teacher per kid. And it's kind of like the calcium atom. There's 1 proton for every electron. They're attracted to each other. But now let's say I have 20 teachers and only 18 kids. I've got like 2 extra teachers that can help to keep an eye on 18 little kids, which, I mean, they could go off and be crazy. I don't want to lose them. And so it's just more charge per electron, more positive charge per electron. So that nucleus only has to hold on to 18 electrons versus 20. And so, yeah, it's going to be harder to remove any of these 18 electrons. The other way you could think of it is this. After I've lost the 2 valence electrons, now look at what's left. Nice full orbitals. I don't want to lose any of those electrons. Those are my stable electrons. And so, yeah, now it's going to take a lot of energy to remove like an electron from the 3p6. I don't want to do that. Those are full stable orbitals. It would take a lot of energy to remove an electron now from stable full orbitals. And then finally, the calcium ion will have a smaller radius versus the calcium atom, because now I've lost those electrons in the 4th energy level, so my highest energy level is only the 3rd. Cool. So let me know if you had any questions or you want any extra explanation on anything that you saw in this quiz.